Hi friends, in this video, let us discuss about dangling pointers. So a dangling pointer is a pointer which points to a memory location which is deleted or freed. That is, a pointer which points to a location which does not exist. Let's see the possible ways where a pointer acts as a dangling pointer. First, holding address of out-of-scope variables. Say this example program, in main function we create an integer pointer ptr. Suppose it is created at address 1024. Now in a block we create integer variable I and assign the value 10. It is created at address 2024. Now we have ptr equal to %I. So ptr will store the address of I which is 2024. After the end of the block, the variable I goes out of scope, but ptr still points its address. So ptr became a dangling pointer, that is, it points to something that is not meaningful now. During the program execution, some other variables can be placed on the same memory location 2024 which might cause a problem. So what is the solution to this problem? After using the pointer, make it as null. Thus we can avoid such issues. Next case is returning address of local variables from the function. See this example program, we have the main function and a function get. As we know, execution begins from the main function. So main is pushed into the stack, and here we have int star ptr equal to get. That is, we create an integer pointer and we call the function get, and whatever the function is returning will be stored in ptr. So control goes to get, also it is pushed into the stack. Here we have an integer variable I created and initialized with 100. Suppose it is created at address 5024. Now we return address of I to the calling function main. So it will be stored in ptr. But the function get will be popped out from the stack since its execution is completed. The memory which is occupied by the function will be available for further use. But the pointer in the main function still points the memory location 5024. A further function call may occupy the same memory location which might cause an issue. Let's do some experiment to understand the behavior. Let's create one more function and call it. Here the function is fun and it creates a local variable named var and assigns the value 250 into it. This local variable may use the memory location 5024. Let's print the value of dangling pointer ptr. It will be printing the value 250. But actually we stored the address of I in ptr, but now we got the value of var. We did the same experiment on different operating systems and the outputs are in Windows 250, in Mac OS 250, in Linux it is segmentation fault, co-dumped error. This is why we should avoid dangling pointers. We can do it by making the pointer to null after the use. Next case is deallocating dynamic memory using free function. See this example program. Here the malloc function will allocate 8 bytes of memory and return the base address to the pointer p. Now, if we free the pointer p, the dynamically allocated memory will be deleted and it becomes available for further use. But the pointer p will hold the same memory address. Now p will act as a dangling pointer. Again, let's do some experiment on this to understand the behavior better. So see this program, we are creating int star p and using malloc function we are creating dynamic memory and storing 1 in p of 0 and 2 in p of 1. After that we are freeing the pointer p. If we again allocate dynamic memory for another pointer q, the same memory location may get allocated to q. Now both p and q point to the same memory location. Now we are setting 100 to q of 0 and 200 to q of 1. Now if we print the data using pointer p, it might print the pointer q's data. Here data of pointer q, which is 100 and 200, will be printed. Again the solution is we need to set the deallocated pointer p to null after using it. We did the same experiment on different operating systems and the outputs were like this. In Windows we got 100-200, in Mac OS we got 100-200, in Linux it was 100-200. So it is important that once the pointer task is over, we need to set to null. Otherwise, it might cause unexpected behavior like this. So that's all, and thank you for watching this video.